All right, welcome back. So we're going to do number 8 in the book, which says, find a general solution to the given equation. Oop. Getting so used to writing in cursive, I'm sorry. So find a general solution, and we're given y triple prime plus y double prime minus 2y equals x e to the x plus 1. Okay, so the first thing we're going to have to do is the same thing we've been doing all along. We're going to have to find the homogeneous solution first. I know, sucks, but we're going to have to. We have to factor this thing anyway, so we're stuck with that. Okay, so let's start by factoring this thing. So characteristic equation is going to be r cubed plus r squared minus 2r, sorry, no r there, okay, because the r goes on the y prime, equals 0. Now, one of the things that's nice about this one, we can immediately see that r equals 1 is a root, right? 1 plus 1 minus 2 equals 0, so r equals 1 has to be a root. So we can factor out r minus 1, okay? I'm just going to do that by synthetic division. So 1, 1, 0, negative 2. Okay. 1 goes down, 1 comes up, 2 goes down, 2 goes up, 2 goes down, 2 goes up, 0. So what we have here is, again, r minus 1 times r squared plus 2r plus 2. Okay, now r squared plus 2r plus 2, that's a quadratic. I can't factor that without the quadratic equation. Well, I could with completing the square, but we're going to factor it with quadratic equation. Okay, so r squared plus 2r plus 2 equals 0. R equals negative 2 plus or minus square root of 4 minus 8 over 2. So r is negative 1 plus or minus I. Okay, so that means we're going to have these e's and also these cosines and sines, right? Okay, so what is our homogeneous solution? Our homogeneous solution is y0 of, I think this is x. Yes, x equals c1 e to the x. That's from the r equals 1 plus c2 e to the negative x cosine of x. That's from the negative 1 plus and minus I. And then we also need a c3 e to the negative x sine of x. Okay, so that's the homogeneous solution. Okay, now let's write this equation in terms of our linear operators. So let me write this. Okay, so now one thing I'm going to do, I'm going to write this a little bit differently up here. So r minus 1, in order to match sort of the form that's on that page that I was telling you on page 334, I'm going to write r squared plus 2r plus 2 as r squared plus 2r plus 1 plus 1. Okay, let me move that down a little bit. So now I'm going to write this as r minus 1, r plus 1 squared plus 1 equals 0. Okay, so this piece here is what's accounting for the cosine and sine, right? So the r plus 1, that's the e to the negative x. And then this plus 1 is the cosine of x sine x. Okay? So let's write this equation now in terms of our annihilators. So this equation is now d minus 1 d plus 1 squared plus 1 times, let's call it y of x, equals x e to the x plus 1. Okay, so far so good? Golden. All right, now what we want to do is now we're actually getting to the part where we're doing something new. Okay, well, we also did that. That was new, but now we're getting to the part that makes this cool. We want to annihilate the right-hand side. Okay, so how do we annihilate x e to the x? Okay, we annihilate x e to the x, we need a d minus 1 squared times, that's what we need. We need d minus 1 squared, right? Okay, d minus 1 won't annihilate it. D minus 1 annihilates e to the x. Okay, but d minus 1 squared annihilates x e to the x. So that's what we were talking about over here. Okay. In order to annihilate the x e to the x, okay, we need the squared term. Okay, so let me write that down over here. D minus 1 squared x e to the x equals 0. And how do we annihilate 1? We annihilate 1 just by deriving, taking the derivative. So d times 1 equals 0. So what we're going to do is we're going to multiply both sides of this equation on the left by d minus 1 squared and d. So we're going to get d minus 1 cubed d plus 1 squared plus 1 y equals, and when we act with d and d minus 1 squared on the right-hand side, we get 0 on the right-hand side. Okay. Okay, now we can write out what is the form of our solution. Okay, so our solution, our y of x, is going to be, so we have the d plus 1 squared plus 1, that's going to be, let's write it as c1 e to the negative x cosine x plus c2 e to the negative x sine x. Now we have plus, now we have d minus 1 cubed. D minus 1 cubed, that means we're going to have c1 e to the x, c2 x e to the x, well, some constant, so let's say c3 e to the x, C4x e to the x, and C5 x squared e to the x. Okay? I miscounted. It happens. And now the D means we're going to have a plus C6. Okay? Now, so far we're doing good. Now, we have to ask ourselves, what is part of the general solution? Okay, what is our homogeneous solution? So these pieces were already part of the homogeneous solution. Okay, so those were already part of the homogeneous solution. Okay, so that means that this is going to be our particular solution. Okay. All right, I'm gonna go ahead and pause this. We're gonna go into a new video because we're gonna actually, the next part, this is actually the answer to number 4. We're gonna go into number 8 where we actually find C4, C5, and C6. Okay? All right, I'll see you in a second.